Okay, so here's a picture. I'm going to draw a simple picture of a flagpole. Right? It's got a flag. And because of the wind, this is vibrating back and forth like that. It makes sense, right? Huh?
10 centimeters?
Yeah. So it's from, if you're looking from far away, it's not going to look like it's moving much, right? But it is vibrating back and forth. So this kind of vibration motion where there's a fixed axis of motion and then it goes back and forth, right? This can be modeled with trig functions. Okay. So doesn't that sound like, initially you're fixed at a particular place and it goes up and down? Right? It does, right? Okay, so look, it says the top sways 10 centimeters to the right. So let's say this represents right, moving right, which means if you go down, it's left. Okay? And this is time. It tells us initially it's here, it's resting. And then it starts moving right. And then down. True? So now this is time. How long does it take to do this once?
1 minute.
So it says every minute it does it 240 times. So how long does it take to do it once?
Over 60.
Okay. Okay, so I think we should maybe consider the time in seconds instead of minute. So this is 240 times in 60 seconds, right? I'm interested in how long does it take to do it one time, right? How do I change this into 1? Divide by 240, right? Right? We're not going to change it into 1 time? One time it takes, what is that? 1/40 of a second. So this is 1/40 of a second. Okay, so the period is 1/40 now. Okay, 1/40. If I just say, because the amplitude right now, the amplitude is 10, right? This is going to be 10 sine of t. But then what's the period now? What's the period? The period is 360, right? This will be 360, not 1/40. So you know that if I shrink it, we can eventually shrink it to 1/40, right? So the period is actually 1/40 right now, and that has to equal to 360 divided by the number I'm going to put in front of the t. That gives you that. What does that do? That does a horizontal compression, right? Remember, it compresses the graph. Philip, are you following?
Yes.
Yes?
Yes.
So we can solve for k here. K is equal to a pretty large number, 40 times by 360. What does that give us? Okay, that's what k is. So therefore, our equation, where y is the position of right and right, position, it might be better to actually just say p for position. So the position of the pole is 10 sine of 14400t. Okay, that models the shaking of the pole motion. Okay. Okay, the important part is, do you understand, like, every step of the way how I translated what's happening into a sine function? Is there anything here that didn't make sense? Right, it's this thing. I mean, realistically, if I were to draw this, if you were to look at it like a like a computer monitor of the motion, it'll just look like this. Like it go up and down like that. You know what I mean? Because the pole shaking so fast with the wind. But if you zoom in, it looks like this.